Section 8.4, multiplicative inverses of matrices and matrix equations. The n by n square matrix with ones down the main diagonal from upper left to lower right and zeros elsewhere is called the multiplicative identity matrix of order n. These are examples of these identities. Notice that the diagonal has ones. Everywhere else it has zeros. So a 3 by 3 matrix, you have ones on the diagonal, should be a 1. And everywhere else would be a 0. Let A be an n by n matrix if there exists an n by n matrix A inverse such that A times A inverse is equal to the identity matrix, and if we reverse them, A inverse times A is also equal to the identity matrix. Then we say that A inverse is the multiplicative inverse of A. If a square matrix has a multiplicative inverse, it is said to be the invertible or non-singular. If a square matrix has no multiplicative inverse, it's called singular. So for example, if we want to show that B is a multiplicative inverse of A, then what we need to do is multiply A times B and so if we multiply this, we have 2 times 1 is 2, 1 times negative 1 is negative 1. If I add those, 2 plus negative 1 is 1, 2 times negative 1 is negative 2, and 1 times 2 is positive 2, so that gives me a 0. 1 times 1 is 1, 1 times negative 1 is negative 1, so 1 plus negative 1 is 0, and 1 times negative 1 is negative 1, 1 times 2 is positive 2, and so you can see here that we get the identity matrix. However, we also have to multiply B times A, so if we multiply B times A, we get 1 times 2 is 2, negative 1 times negative 1 is negative 1, so that gives me a 1. 1 times 1 is 1, negative 1 times 1 is negative 1, that gives me a 0. Negative 1 times 2 is negative 2, times 2 times 1 is 2, so we add those, we get 0. Negative 1 times 1 is negative 1, plus 2 times 1 is 2, so that gives me a 1. So you can see here that they both give us the identity matrix. So we say that B is the inverse